This video is going to take you through the process of converting complex numbers into polar complex numbers. Polar should always make you think r and theta. The first thing we're going to do is make a triangle using the real axis as one of our legs. This right triangle should look very familiar at this point. The next thing I'm going to do is find r. Now I know that this point is 2 plus 4i. So we have 2 and 4. So finding r is really just using the Pythagorean theorem. So r is the square root of 20. Next we're going to find theta. This angle right here, the angle between the real axis and this ray is what is theta. Now I know we know the opposite, the adjacent, and the hypotenuse, so we could really use sine, cosine, or tangent. We're going to use tangent, and the only reason is that we were given, as our point, we were given the opposite and the adjacent, so there's less room for error there. So I know that theta is going to be the inverse tangent of 4 over 2. So theta equals 63 degrees. Now we're in the first quadrant, so I don't actually have to do anything. It's just 63 degrees. Now this last step is the hardest. I'm going to set up sine and cosine of theta. So I can say sine of theta equals opposite, which is 4 over the hypotenuse, and cosine of theta equals the adjacent, so 2 over the hypotenuse. Now it's not initially clear what we want to do with this, but the important thing to notice is that our original point, 2 plus 4i, has a 2 and has a 4. It's not a coincidence that 2 and 4 show up in the sine and cosine. So I'm going to write these in terms of that 2 and that 4. So I'm going to multiply both sides by the square root of 20. Square root of 20 times the square root of 20. So I'm going to end up with the square root of 20 times sine equals 4. And the square root of 20 times cosine equals 2. Now I have a 4 and a 2 and the 2 and the 4. And I'm going to substitute in. So everywhere I see the 2, I'm going to write square root of 20 cosine. Everywhere I see the 4, I'm going to write square root of 20 sine. Let's make it a little bit bigger so it's a little more obvious what's happening. So I'm going to take this, which is the same thing as 2, and just rewrite it. So I have square root of 20 cosine theta, and that totally takes the place of the 2. Plus, now I'm going to rewrite this where I had 4, square root of 20 sine theta, and then I still have that times I. Now, I want you to notice that both of these pieces have the square root of 20. So I'm going to factor that out. Factoring never goes away. What am I left with? Well, I'm left with the cosine of theta from the first term, plus, and then I have the I still, times the sine of theta. The square root of 20 is outside the parentheses. One last thing to do. I actually knew theta. Remember, we found that to be 63 degrees. So I can totally rewrite this as the square root of 20 cosine 63 plus I sine 63. Now I know this looks really messy, but it is going to have very important properties in the next few days. So we need to practice putting things in this form. Let's look at this in general. So instead of calling this point 2 plus 4i, I'm just going to call it a plus bi. So I'm going to call this part a, my real part, and this b, my imaginary part. Now, we aren't going to be able to find r. You guys know how you would find r. You use the Pythagorean theorem. We know r is going to be the square root of a squared plus b squared. But we can't really find it right now. Same thing with theta. We know we're going to find theta by using the inverse tan of b over a, but we still really can't find it. But what we can do is this last step, step 4, write a and b in terms of r and theta. So I can say the sine of theta, whatever theta is going to be b over r. And cosine of theta, whatever that is going to be a over r. Now, just like in the last example, I can multiply both sides by r of both equations. So I'm left with b equals r sine theta, and a equals r cosine theta. Now, remember my point was a plus bi. So I'm going to replace, I'll write it again, a plus bi. I'm going to replace a with r cosine theta. So a goes away, and I have r cosine theta. Plus, and I'm going to replace b with r sine theta. So I have r sine theta. And then I still have that times I. Now to make this a little bit nicer, we factor out the r. So you have r parentheses cosine theta. And then just for convention, we usually put the I first, sine theta. And this is actually our formula. So you don't have to go through the whole draw the triangle, find the cosine, find the sine every single time. You can just jump right into using this formula. Here I've just written out the formula so you can go back and reference it. We have that a plus bi is just equal to r cosine theta plus I sine theta. Now, down here, just so you know how to find r, it's right here, and how you find theta is right here. And of course, with theta, we're going to be where? Quadrant. We have to be very careful what quadrant we're in. Let's do one last example, and this time I'm actually going to use the formula rather than going through the whole triangle process. Now, first thing I should do is probably identify my point. So it looks like 1, 2, 3, 4, 5. Looks like we have -5, -4i as our point. So I'm going to go through my steps. First, I need to find r. So I know r is just the square root of a squared, -5 squared, plus b squared, -4 squared. So r is going to be the square root of 25 plus 16. So r equals the square root of 41. Awesome. Now theta is just the inverse tan of -4 over -5. Now remember, this is the one time that drawing the triangle is really important. This is the theta we are finding. It's not the theta we're going to want eventually. Eventually, we're going to want this theta. So we're going to have to do some addition. So I get that theta equals 39 degrees, but that's 39 degrees below this x-axis. So I really need to add 180 to get my real angle. So my real theta that I'm going to end up using is 219 degrees. Remember, in the third quadrant, you're between 180 and 270. So if you have an angle that's not between 180 and 270, you need to stop and rethink, try to figure it out. Okay, well now I have my r and I have my theta, so all I'm left is plugging into the formula. Remember the formula is r parentheses cosine theta plus I sine theta. So square root of 41 cosine 219 plus I sine 219, and I'm all done. Now, to finish your homework, it would be awesome if you could try at least one problem on your own. We're going to work on them in class, but if you could try one before class, it's really going to help you. Good luck.